Question 10. The height above ground, each meter of a passenger on a roller coaster can be modeled by the differential equation dh over dt equal to h cos 0.25 t over 40. And then where t is the time in seconds from the start of the ride. Okay, so it's a differential equation. So let's try to integrate that. So we have dh over dt is equal to h times by cos 0.25t divided by 40. So we can move all the h to one side and then keep all the t to one side. So I will divide by h for both sides. Then we have 1 over h and then dh, and I times by dt for both sides at the same time. So we have cos of 0.25t over 40 and then dt. And we integrate it for both sides. And then 1 over h, that's just ln h. Cos will integrate to positive sine. So sine of 0.25t. And then because this is just a linear expression, so we only need to divide by the coefficient of t. In this case, 0.25. So 40, just the coefficient still the same. So just over 40 in the denominator plus c. So simplify this a bit. So ln h equal to sine of 0.25t. So 0.25 times 40 is equal to 10. So divide by 10 plus c. So that means h is equal to e to the power of, so divide by 10 just same as 0.1. So that would be e to the power of 0.1 sine 0.25t and then plus c. So then we can check that into h equal to e to the power of 0.1 sine 0.25t times by e to the power of c, which is another constant. So normally we just use a capital A to represent e to the power of c. So now it's time to substitute in the condition to work out the constant A. So given that the passenger is 5 meters above the ground at the start of the ride, so that means when t equal to 0, h is equal to 5. So substitute that in. So h is 5, and the a times by e to the power of 0.1 times by, so sine of 0.25 times by 0. So anything times 0 is 0. Sine 0 is also 0. So 0.1 times 0 will also be 0. So just 5 is equal to a times by e to the power of 0, which is 1. So a is equal to 5. Then we will have h equal to 5 e to the power of 0.1 times by sine of 0.25t. That is the form we want in part A. And in part B, state the maximum height of the passenger above the ground. So this is just an exponential diagram. And then we know for the exponential diagram, it's always look something like that. So the bigger the power, so then the bigger the h. So because one is increasing, another one also increasing. So we just want to looking for what's the maximum value of the power can be, and then we pretend not be the maximum height. So in the power, it says 0.1 sine 0.25t. So we know sine is between 1 and -1. So 0.1 sine 0.525t has to be between negative 0.1 and then positive 0.1. So the maximum possible value is just 0.1 as a power. So h has to be equal to 5 times by e to the power of 0.1. So put that in the calculator. So 5 times by e to the power of 0.1 is equal to 5.53 rounded. That would be the answer, meters. And then for part C, the passenger reached the maximum height for the second time. So for the second time, t seconds after the start of the ride, find the value of t. So we let the power to be 0.1 to get the maximum. So that means sine 0.25t has to be equal to 1 to make the power 0.1. So then to solve this one, that would be just 0.25t equal to So sine inverse of 1 is just pi over 2. And then plus another 2 pi, that would be 5 pi over 2. So because with time cannot be negative, so we're only looking for the positive time. And then because it says for the second time, so this pi over 2 is the first time reach the maximum height, but they want us to find the time, which is the second time reach the maximum height. So that has to be 5 pi over 2. So then ignore this one. So t is just equal to 5 pi over 2 divided by 0.25. So putting that calculator should be, so let me see, 5 pi over 2 divided by 0.25. That's 10 pi. And then 10 pi is just same as 31.4. And then time is in seconds. So 31.4 seconds. That would be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.